Welcome everyone. This is Shivam Nikam, roll number 34, along with Anay Naik, roll number 33, and this is our DCT IA2 on the topic of bridging collaborative machine learning with blockchain, a case study on flowchain framework.
Coming to the abstract of this research paper, the abstract of the research paper, Federated Learning Meets Blockchain, a power consumption case study, provides a concise overview of the study's key objective and finding. It highlights the emergence of federated learning as a promising approach for collaborative machine learning while addressing the limitations of traditional centralized methods. The paper introduces the integration of blockchain technology to enhance the robustness of FL, emphasizing the needs to access its energy and power consumption. The research focuses on flowchain, an architecture that combines FL and blockchain, and demonstrates that power consumption is closely linked to complexity of machine learning models. The introduction. The introduction section of the paper lays the groundwork for understanding context and significance of the study. It recognizes the ever-increasing volume of data generated from various sources and challenges posed by privacy laws and data regulations. It introduces federated learning as a solution to leverage distributed data for collaborative machine learning without centralizing sensitive information. This section highlights the process of FL involving local model training by participants and subsequent aggregation to create a global model. It identifies the drawbacks of traditional approaches such as the use of a parameter server, including single points of failure and scalability issues. To address these concerns, blockchain technology is proposed as a solution to enhance the robustness of federated learning. The introduction acknowledges the significance of energy consumption as a hindrance to widespread blockchain adoption, especially in light of chemical change discussions. It emphasizes the need for an analysis of the energy and power consumption of FL and blockchain integration, which is the primary focus of the study. The background section provides essential context by delving into the core concepts of federated learning, blockchain technology, and flowchain framework. FL is described as a collaborative machine learning technique that allows global model training without centralizing the data. It outlines the process of FL rounds and introduces the challenges associated with traditional parameter server-based approaches, including trust issues and scalability limitations. The section then introduces blockchain technology as a decentralized and immutable ledger system, emphasizing its role in ensuring data integrity through consensus mechanisms like proof of work and proof of stake. It also highlights the use of smart contracts for automating processes on the blockchain. The introduction of flowchain framework is significant as it represents the integration of FL and blockchain technology. Flowchain employs Hyperledger Fabric and smart contracts to store and aggregate machine learning models, enhancing trust and eliminating the need for a centralized central server. Federated learning. Federated learning is a paradigm shifting approach that redefines machine learning practices by enabling collaborative training without the centralization of sensitive data. It operates by having participating entities or clients independently train local models using the private datasets. These locally trained models are subsequently aggregated to construct a robust global model. Key federated learning algorithm encompass federated stochastotic gradient descent and federated averaging. Blockchain technology. Blockchain, a decentralized and immutable ledger system, establishes a secure and transparent framework for recording transactions. It employs consensus mechanisms such as proof of work and proof of stake to ensure the validation and integrity of data. Smart contracts, which are self-executing agreements, automate the predefined processes on the blockchain. Over to you, Shivam.
So now looking at the background of the flowchain framework. Flowchain represents a pioneering integration of FL with blockchain technology. Employing Hyperledger Fabric as its foundational infrastructure, the integration guarantees decentralized storage and aggregation of machine learning models. The management of the aggregation process is facilitated by smart contracts, thereby enhancing trust among the participating entities. Notably, Flowchain eliminates the need for a central server, assuring the immutability and authenticity of data. Power consumption model. The power consumption model section introduces a critical aspect of the study, focusing on the estimation of power consumption within the context of FL and blockchain integration. It introduces an integrated power consumption model that considers energy utilization by FL clients and blockchain nodes. The section provides detailed equations that precisely defines power consumptions during FL rounds, emphasizing its direct correlation with the number of participating clients and nodes. It underscores the impact of machine learning model complexity on power consumption, offering valuable insights for real-world applications. The power consumption model serves as the foundation of the subsequent experimental evaluations, allowing a deeper understanding of the energy dynamics in the context of flow chain. So now we'll evaluate using the power consumption model. In the evaluation section, there are a series of experiments conducted to assess the power consumption of the flow chain framework in two distinct scenarios. So the experiments involve the use of fashion and CIFAR10 datasets with varying level of neural network complexity to stimulate real-world condition. The section presents the result of the experiments, highlighting substantial differences in the power consumption during key phases. including smart contracts initialization, transaction execution, and client connector creation. It emphasizes the complexity of machine learning models, significantly influencing power consumption during the transaction execution phase, with more complex models leading to higher energy demands. The evaluation section provides a comprehensive analysis of the experiments, including observations, insights, and graphical representation of the consumption trends. It concludes that while the power consumption escalates with model complexity, the overall power consumption remains within acceptable limit. This suggests that the integration of FL and blockchain, as exemplified by the flow chain, is suitable for deployment even on low power devices, enhancing the practicality of decentralized collaborative learning models. Observation. Intriguingly, the finding accentuate the substantial escalation of power consumption commensurate with the complexity of machine learning models. Notably, during the transaction execution phase, the energy demand experiences a notable surge when dealing with complex models. Nevertheless, the overall power consumption remains well within the acceptable threshold, rendering the integration suitable for deployment. So, in conclusion, the paper summarizes the key findings and implications of the study. It underscores the significance of integrating federated learning with blockchain technology, as demonstrated by the flowchain framework, in advancing collaborative machine learning methodologies. Rooted in empirical evidence, the study elucidates the nuanced energy dynamics associated with federated learning and blockchain integration. It emphasizes the practicality of decentralized collaborative learning models in real-world context and underscores the need for a comprehensive understanding of the energy implications of these technologies in shaping a sustainable future for collaborative machine learning. We have also discussed a few future implications as given in the paper, which highlights the directions for further research. It encourages the further endeavors to optimize the configuration of the federated learning clients and blockchain nodes, enhancing the operational efficiency. Additionally, it calls for innovative research into energy efficiency consensus mechanism to facilitate the seamless and eco-friendly integration of FL and blockchain technologies in diverse applications. The study's comprehensive analysis and findings pave the way for ongoing exploration and innovation in the field of decentralized collaborative machine learning. So, in all, the whole federated learning and blockchain nodes can be integrated and deployed, and it is a viable solution for a collaborative machine learning environment.